Okay, I just transitioned the stream. Let's give it a second to come on. Someone from the chat box, let us know if you can hear us. Usually there's some latency. I think they'll be able to hear us in a second. Okay, welcome. I believe everyone has the agenda. I will share it in our chat box there. Cool. So, first thing on agenda, client updates. These can be as long or brief as you want. I know we've been fiddling with the spec a lot, which we can talk about. So I don't expect too much progress and a lot of people catching up. So if anybody wants to start us off, go ahead. Y'all always make me call somebody out. Nimbus, give me an update.
Hey, so we caught up with the latest spec changes. So now we are at most 3 days off. It's, I guess, quite a feat given all the changes that were going on. We have a NIM wrapper working for libp2p daemon. So now we tested, we can have 2 team members chatting through libp2p daemon with NIM wrapper. We have mini target of running kind of demo Bitcoin node for December. So in order to do that, we reorganized our repo. And we cleanly separated what is spec and what is client implementation or network protocol and only Nimbus. So it should be easier to track what is custom and what is spec in our repo. And also, we will start implementing our third BLS signature aggregation scheme. So I hope there won't be a fourth. But we feel a real need for common tests for that. We checked Zcash and Relic tests, but they are using RNG. And Chia network tests are good, but we departed from Chia BLS signature scheme. And as a suggestion, I think if we can have a test some kind of Alice, Bob, and Eve key tests like what is done in ETH key repo. I will add the link in the chat box. That would be nice, and I can after add them as a sanity check to the YAML test file. And if it could be in the in the appendix of the BLS spec, some kind of sanity check, it would be nice. That's all for me.
Great, awesome progress. Yeah, the testing stuff is something I want to be focusing on the next couple of weeks. So I'll get in touch with you and we can coordinate on the BLS tests. Thank you.
Just a quick question.
Yeah.
How do we differ from Chia for the BLS stuff?
In your, I'm talking about the pragmatic BLS aggregation in your post on ETH research. Chia is using big and slow G1 and small G2, and in the update from Vitalik spec, it's the opposite for ETH 2.0. This is a topic I raised yesterday, actually.
Okay,
to get some clarification.
That's kind of strange because I thought Chia and us were doing the same thing. Maybe I'll double check the spec. Maybe there's some sort of confusion.
Probably.
Yeah. and if there are differences, I wonder what their rationale is for having big puppies and small signatures. It would be definitely good to just cross-check and see whether or not our situations are different.
Cool. Who's next? How about Lighthouse?
Yep, it's been a little bit quiet this fortnight for us. We've had some kind of staffing challenges, I guess, people on leave. But we're expanding the team, which has been quite successful. So we're going to be hard back at it next week. So have something for you next meeting.
Great. How about Parody?
No major update.
Cool. Let's start.
So now we're, since we're trying to let the spec kind of stabilize a bit, we've been focusing on converting to TypeScript. So we've been trying to create native types for the different types in Eth2.0, like UN hash 32 and all these different types. That's the main thing that we've been working on. We're slowly starting a BLS signature aggregation library as well. So if Mami, later we can like talk about how that's going for you, that'd be great. Otherwise, we have no other major updates.
Great. Thank you. How about the PyVM side?
Me, right? Hi.
Yep.
Hello, everyone. So yeah, Danny and I both were helping the reviewing of the spec in these 2 weeks. So not much big process on Python side except the reworking on the data structures and the help her functions. And on the other side, we have a internal consensus of the testnet, the Trinity testnet, just for Trinity, and it's a MVP, and what are the components of the MVP will contents. So I post the link on the chat, and that's our updates, I think. Or anyone else want to add a comment?
No, I think you covered it. How about Harmony?
We are catching up with the spec, with the latest updates, and we have integrated Milagro and using it for BLS verification implementation. Have some numbers and for aggregation and for verification and with relate to Nimbus, it's like 1.5 to 2 times slower, but not sure we can judge about these numbers at the moment. Need some simulations or test network to understand whether they are good or not. Yep. So yeah, that's all for now.
I would add to that the Nimbus, we haven't really optimized things yet. So even those numbers are, to be taken with a grain of salt.
Yeah, but as I understand, you have used Milagro, right? Or
Yeah,
did you
Milagro.
switch?
Yeah, sure.
Yeah, and that's why we used like a reference to some low-level implementation of the same stuff.
Right. I have a question. I remember a few months ago there were concerns over licensing in Milagro because maybe there was something that was unattributed that had been copied into the repo. Am I remembering that correctly? Does anybody have any details on that?
I think it was a misunderstanding because Milagro is Apache 2.0 fully, but it's a Relic and a Chia network library that can have optional dependency on GMP, the GNU multi-precision math library, and those will bring either LGPL or GPL requirement. But Milagro, I don't think there is an issue.
Okay, but are those, to utilize the BLS signatures, you don't need to bring in those dependencies?
It's best if you bring them if you are using a Relic, because there is a 3 times speed difference. Like it's 3 times faster if you use GMP with a Relic or a Chia BLS aggregation.
Okay, I see. Okay, thanks. That clarifies it for me.
And do you use those dependencies?
I don't, because I use Milagro due to the licensing.
Cool. Okay. Who else? Prismatic.
Hey everyone. I'll start with some updates with BLS, given that's the topic of discussion. So we're using the Harumi library, which is created by an XDefinity person. They're using an underlying cryptographic library called MCL, which uses GMP. However, he actually just removed the dependency on GMP yesterday. So we'll have to do some benchmarks to figure out if if removing GMP is how slow that's going to be. Aside from that, he's also working on optimizing a Miller loop so that we can have kind of signatures in G2 and then public keys in G1. So we'll be doing a lot more work on that kind of once he pushes those changes, hopefully in the next few days. Yeah, I think we should probably see a speed up on the order of like 3x without GMP, which is unfortunate, but that's still left to be seen. Aside from that, we've been refactoring our code base to match having a single beacon state. That was really nice. It cleaned up, like it removed like thousands of lines from our code base. And we also have a Kubernetes kind of configuration in place for a testnet. We have basically a DHT discovery working with a relay node that helps traffic kind of, inbound connections to nodes in the cluster. And we also have a boot node for the beacon nodes. So Preston from our team has been putting a lot of work on that front. Aside from that, we've mostly been focusing on aligning with the spec. There have been so many changes, a lot of refactors to be done. But yeah, I think we're just cleaning up our repo, fixing things up. And then after that, we'll be ready to put in new features and work on more of that. We also have a bounty worker working on a pure Go BLS 12.3D1 implementation. So he's basically basing it off the Rust implementation and trying to get close to the same amount of performance. But yeah, that's still kind of to be seen. He has some benchmarks, but it's still a little bit slow. So hopefully we can get more optimizations on that front. But yeah, I think that's all. Thank you.
Great, thank you. How about Pegasus?
Hi, hi, I'm Joe Long with the Pegasus team. In the past 2 weeks, we brought in 3 new team members to work on that. So we have about 5 people working on this now. We started implementation of simple serialization, but then we put that on hold while we implement some of the primitive types that were laid out in the spec, because you can't serialize it without having the thing. So we started writing a Solidity version of the validator relay contract. And a team member of ours, Johnny Ray, worked with Raul from Protocol Labs on a libp2p daemon. They compile as a shared object library so that you can interface libp2p, with your client regardless of the language. And I'll post a link in the chat box shortly of that repo. And that is our updates.
Great, thank you. Curious, why are you implementing the contract in Solidity?
For fun. No. We're yeah, it's part of our understanding of how the validator relay contract works.
Okay, cool. Yeah, that makes sense. Thank you. Did I miss any teams before we move on to research updates? I don't think so. Okay, cool. We'll move on to research. Who wants to start?
I guess I can start. Justin, Danny, Xiaowei, and I mostly have been working quite a bit over the last 1 to 2 weeks to basically get the spec to the point of it kind of being feature ready for what we want to have for phase 0. And it's so the most recent things that we added include there is the tree hashing mechanism, the active and crystallized state merging, then switching back from using cycles to using epochs, which is just a fairly considerable gain in simplicity, and a kind of modification to Casper FFG that fixes a couple of bugs, along with some code that adds in kind of adds in preliminary placeholders for proof of custody, and a couple of other various small things. So it's basically at the point where phase 0 is kind of going through sort of spec rewriting and spec basically cleaning up, making it easier to read, trying to find fixing bugs and simplifying and so forth. On the phase 1 side, there's definitely still quite a bit of work to do, and a couple of fairly significantly different ideas that I'd probably want to try out and think about in terms of exactly how what data routes get committed into the cross the data hash that goes into the crosslink, but that's something that we still have quite a bit more time for.
And one of our intentions with the phase 0 versus phase 1 is to get all of the data structures needed for phase 1, all of the beacon chain related data structures ironed out. So like the proof of custody bits are in phase 0, so that we don't have spaghetti code with respect to the data structures when we launch phase 1. But everyone always signs a 0. So that's kind of the separation of concerns there, but why we're driving forward with at least integrating those data structures.
Yeah, we're definitely designing phase 0 for kind of future compatibility with the array of things that we think will likely end up wanting to include for phase 1 and phase 2.
Right. I mean, I think it is possible, even though we will do our best to have a future compatibility, that we might have to change the format slightly if there's something we find after launch. I'd agree with Vitalik that we are nearing feature complete. There's a few things we want to tweak, but at this point, I'm now in basically a cleanup mode, finding bugs. Just as a heads up, I think there's still a lot of bugs in the spec. I'd say at least 100 bugs. So it's just a matter of finding them and squashing them.
Right, and as we're going to try to get on the forefront of doing that in the Python side, but if you're implementing and you see things that are bugs, note them, because they probably are.
Yeah, that'd be great. And also, I'm kind of thinking about edge cases from a design perspective, things that we want to clean up. And I've also started a pretty large cleanup it's a PR, with like something like 20 commits. So I would just maybe wait a day or two for things to settle before looking too closely at the current spec. One of the things that I'm working on, and it's kind of helping me as well with the fine grain review, is that I'm actually rewriting the whole spec in something that I'm calling the transparent paper. So it's meant to be a little bit like the yellow paper for Ethereum 1.0, but instead of being super formal and unreadable, it's meant to be designed for insight, designed for readability, for transparency. And in addition to the spec, it has things like definitions of every single term, and it has explanations about design decisions and things like that. So I'm hoping to get that out in January, probably end of January. That's my target. And hopefully end of January, we will also have close to finalize the spec on GitHub.
I have a question there. How do you prefer your bug reports, as like pull requests that fix them, or just issues?
If it needs discussion, then an issue. But if it's a clear, if it's what you deem a clear bug fix, then a pull request is fine, and we can discuss it there if need be. I mean, just use your judgment, but whatever makes sense on that particular.
Yeah, I mean, if you do a pull request, I think we'll try to move fast on the pull requests, especially those that are uncontroversial. So I think every day I'll just go through the pull request and just merge what's low-hanging fruit and uncontroversial. So we should be moving faster on that front.
Oh, that's nice.
Leo from the, I think, Barcelona BSC, Barcelona Supercomputing, has joined us today. He was at the client workshop in Berlin and presented some of his work. But now that the spec is getting into more of a stable place, he's interested in collaborating again. And Leo, if you want to do a quick intro, talk about some of your previous work and some of your potential intentions for future work.
Sure. Can you hear me?
Yes.
So what the idea that I have that I had for research on charting was to try to build a simulator that can run in a supercomputer to simulate that we're discussing right now in a higher level. So we don't simulate, of course.
You're cutting in and out, Leo.
Any transaction or any kind of real mining, but okay. I would try to. Is that because of the microphone or because of the connection?
Not totally clear. I'm not sure.
Okay, I would try to talk slower. Maybe that will make it clear. I have already a first prototype of the simulator that can run in about a couple of hundred of processors in the supercomputer. However, this prototype that I have at this point is not completely up to date with the last developments on the spec. It does include the basic things like the beacon chain and the other more basic stuff, but nothing that has been added in the last couple of months. So yeah, in the last few weeks, I have been a little bit busy with my other hat, which is the supercomputer hat. So I had a conference where I had to present a couple of papers, and I was finishing a European project. So there has been no much progress in the last couple of weeks on the charting simulator. However, I did give a talk about charting in a meetup in Barcelona. With the last spec, I exchanged a couple of emails with Justin and Vitalik on that for that talk. So I think I have a more clear vision of where we are right now with the spec, and I hope that in the next couple of weeks I would be able to get up to date with the spec on the simulator.
Great, thank you. And what type of data do you hope to report on?
So the idea is that we want to try to see different aspects of how a sharded blockchain will behave following this spec, and try simulations that cannot be done easily in a testnet or with real clients. So, for example, the kind of experiments that we want to try is like giving different latencies to different nodes, different clients on the network, trying to see if that that could change anchor rate, trying to see different load imbalance between the number of transactions, to see how that affects the number, for example, number of cross-chart transactions, and these kind of things. Basically, there is, I think there is a wide set of ideas that of tests that we can run in the simulator. But I think initially the idea is to have something that runs more or less in a similar way on what we have today. I mean, without charts, of course, but that we can say that more or less the simulator that we have running in the supercomputer kind of really represents at least a blockchain without charts. And then after that, we can more or less say, okay, this could be it's like a baseline, and we can assume that the results of the simulations are accurate as well.
Great. Thank you very much. Any questions for Leo before we move on?
And in this case, also it doesn't make sense.
Cool. And George from Clearmatics, I think you're unmuted. We have a lot of background noise from you. Thanks. Cool. Any other research updates? Anything going on with the Pegasus team? I know you all have a lot of people digging into some network research.
Yeah. So on one part, we continue to work on the tree-based aggregation. So we've got something working, but it's still very basic. It's in Go in the public repository. And we will do more tests in the next weeks. As a part of this, we would like to try the quick protocol in libp2p. So it's something that is currently under implementation in the libp2p team. And we've got some packaging issues, so we will need to wait. So either for this, we will not try quick, either we will try with another library. So we don't know yet, it's something that we need to discuss. We spent some time on these Sybil attacks at the peer-to-peer level. So that's a Git issue on the P2P GitHub that we created. And the idea is that on Ethereum 1, we've got 15,000 nodes, so it's very difficult to take the control of the network. While on Ethereum 2 in the shards, you've got a few hundreds of nodes, so you can have you can add 2,000, 3,000, 3,000 nodes, peer-to-peer nodes, and they can delay the messages. And it's quite important in Ethereum 2 because we know that, for example, for block producers, they have a few seconds to send their blocks, so you can play a little bit with the network. So it's more a topic to take into account that a big issue, but likely we will need to follow up on that. And the obvious solution is to have a lot of peers. This way you can avoid to be eclipsed. But it means as well that you're having less boundaries available because you're going to speak to a lot of people. So if you're interested in this topic, you can have a look. Thanks, Denny, to publish the link. And we're working as well, so something that is still in the thinking process of applying like onion protocol at the P2P level to increase anonymity and to be a little bit more hidden on the network. So we're thinking about this kind of stuff. Likely we will create a few issues in the near future.
Nicola, this is... sorry, I thought you were done. Sorry, continue.
Yeah, I've got last point. So we will do soon a presentation of a tool that we're using for protocol simulations, Wittgenstein. So I will likely put an invite on Gitter if you're interested on this. It will be next week, likely. And I finished. Raul?
Hey, Nicola. It's great to see that you've decided to experiment with Quick. I wonder if these packaging issues that you're encountering, have you been able to open an issue for this in the community?
I think so. I think it's Boaget who created that. And we saw a discussion between you and Sebastian, maybe. And Sebastian wanted to wait on this issue until it's totally finished. The implementation is totally finished.
Okay. If you can, I'm participating in a lot of issues every day. So if you can just send me the link through the chat or somewhere else, I can make sure I keep track of that. That's great. And then on the other hand, you mentioned something about the Tor, potentially Tor transport, and onion transport. Just wanted to point out that this is on the Libby2B roadmap, which is a point in the agenda for later as well. So it would be great to have you pitch in as well and raise the fact that you are looking into that to try to find some alignment and convergence there as well. This is definitely a priority for us going forward.
Okay, so it's great. So I will try to create the issue and to expose where we are as soon as possible.
Perfect, thanks.
Jacek, did you have something to say?
Yeah, I was gonna 2 points. I was gonna ask Nicholas for links to this work, like in the chat, very quickly, so we can read up on it. I'm very interested in the subject. On the other hand, it also feels a little bit like scope creep, feature creep. So there's the question: how much, say, Quick, for example, is that something that we want to target for? I don't know, March, or is that just a fun thing to explore right now and to keep the door open for the future?
Yeah, I will create as well an issue. I wanted to do that on Quick to put as a subject to be discussed, and I don't have any opinion for March. It's likely to be aggressive if we wanted to have this for March. My opinion, it's difficult to have it for March, but it's an opinion.
Yeah, so from Libby2B, Quick is definitely a priority for us. It is true that the spec isn't finalized yet, I think upstream, so it will be, we have been closely following and tracking it, and we're working with the Libby2B, in the Libby2B team, there's a member that's actually engaging with the working group, with the IETF working group, and keeping the implementation up to speed with all the developments there. So we really, and it is being, I think, one of the latest releases of IPFS has a flag to enable the quick transport as well. So it is being tested on an experimental basis out in the open. I think it's good to target or to potentially consider Quick in the medium term, so to speak. Yeah, but I don't have any say regarding specific dates or anything. But yeah, I think it's definitely something to consider and to keep on the map.
What exactly is Quake transport? And can someone share?
So Quick is a UDP-based transport that provides many of the guarantees of TCP in terms of congestion control, in terms of reliability, and a few other things. It also implements multiplexing, protocol stream multiplexing. And it also includes security and encryption constructs on top of the transport itself. So it's basically the best of many worlds over UDP. It allows us to it basically allows us to keep multiple streams open in a similar way as HTTP2. At the same time, it implements DLS-like security guarantees, and all of this with with a number of features such as session resumption, zero round trip negotiation in certain cases, and so on. So it's a very promising protocol going forward. And the reason why Quick is important in this case is because libp2p for now is mostly a stream oriented. It has stream orientation as a primary abstraction. So using UDP constructs, so this is message oriented transports, right now is not feasible with the current abstractions. This is on a roadmap. We do want to potentially in the future create a new set of abstractions on the B2B that it would make it easier to use message-oriented transports, but Quick provides stream orientation on top of UDP. So it's really promising in many directions.
And there are two reasons for us to use it. One, it's something that is going to be used for HTTP3. So it means that it's a universal protocol, and you won't be able to distinguish between basically our peer-to-peer communications and standard HTTP communication. So in terms of discretion, being a little bit hidden on your network, it's useful. And the second reason is hopefully, it's not sure, it's something that we need to look at, but hopefully we will be able to use it to connect to a lot of peers without consuming too much resources. Okay, and it can be interesting, for example, for the attesters. If the attester believes that someone tries to censor them, it's interesting if they can push their attestation to as many nodes as possible. So without maybe being connected full time, but they can connect to a lot of them, just sending a very small message, the signature, and then they're done. So it's very interesting from this point of view. And this. So for March, that's likely difficult, but in 1 year or 2 years, it's likely to be very, very interesting.
Got it. And aside from that as well, the fact that it's UDP based allows for much better opportunities to pierce through NATs and to perform hole punching and many more and different techniques that allow for better connectivity going forward. So there's really many advantages.
Cool. And to be clear, due to the modularity of the libp2p framework, that would be, once we decided to move on that front, it would be a matter of adding that transport to libp2p.
Yeah, that's correct. It's intended this way. It already exists. The transport already exists, and it is operational. It's being used by IPFS already, and with this experimental flag. So yeah, it already exists and it works in that way. Yeah, you just need to add it to your host.
Cool. Thank you very much. Any other research updates before we move on?
Hey, yeah, this is Johnny Ray. I was gonna see and specifically ask Raul about adding, a flag to the libp2p daemon to expose that quick transport. Would that be something that's fairly easy to do?
Yeah, I think so. I think that's something that we can do. If you can just file an issue for that, we'll get it moving.
Cool. Thank you.
Great. On the topic of P2P, the next thing on our agenda is discussion of P2P discovery protocol. I know that in a lot of discussions, especially around DevCon, there's been a general coalescing of thought on moving towards Discovery v5 as the P2P discovery protocol. I just wanted to bring it up in this meeting so that we could talk about it, decide if it is ready, if it meets our needs, and if it's feasible to start using now and for people to start building it. Does anyone want to speak to Discovery v5 and its use in our protocol?
I can maybe say something about it. I like it. My initial concern was that it's not fast enough, but I don't think that's correct. I estimated a little bit, and it should, yeah, not be too slow. I also think that it's not too difficult to implement as long as there's a Kademlia implementation, because it's built on top of Kademlia, and once Kademlia is ready, then building it on top should not be too much work. The only problem I see is that the spec is not very well written at the moment, and there's some stuff missing, and there's also no wire protocol or anything about this. But that's something that I guess we can work with Felix and the existing Ethereum networking team with and solve that, I think.
Got it. And Discovery v5 specifically implements this feature that we need, which is topics and advertising the topics that you subscribe to. Are there any other protocols, any other Discovery protocols that do give us this feature set and that are under consideration? Does anybody know?
Hi, Ankit this side. So I'm looking into a similar kind of a vertical where there is a peer-to-peer discovery. Last week I did a lot of research, and I figured out that there is something like there is some startup who did who built something like an SDK. It's like a peer-to-peer network system which basically connects either the Bluetooth, Wi-Fi, okay, I think I'll send you the link on the chat. So basically, it requires the Wi-Fi, Bluetooth, or Bluetooth Classic. It's especially built for the IoT devices, and they are working. So they basically, the mode of connecting is, there are two modes of connecting the system. First one is a proactive protocol, and second was the reactive protocol. So the problem with the proactive protocol is that it's good in the finding the nearest devices, but it's difficult when it comes to the scaling. So they are right now looking into the reactive discovery protocol model. So I'm a bit curious if anyone is working on the similar kind of approach or something. I'd like to collaborate on this vertical.
What was this called?
Sorry?
What was the name of this protocol?
Yeah, it's Hola protocol.
And I'm sorry, I'm not sure if I understood. Are you proposing this as an alternative to Discovery v5 for suiting our discovery purposes in Ethereum 2.0?
No, I'm just trying to understand how Ethereum 2.0 is trying to work on this.
Sorry, I'm not
I think,
certain.
okay.
Share the link.
Sorry.
Yeah,
I mean,
yeah.
please continue. I mean, I'll just message those stuff.
Cool. Thank you. Okay, so let's figure out for the next call what needs to happen, and maybe just get in touch with Felix to make Discovery v5 happen, so that people can move on it. Yannick, if teams were wanting to use a discovery protocol right now and only use the beacon subnet instead of using all the shard subnets, would targeting Discovery v4 make sense in that most of the feature set of v4, like the underlying components of v4, is what v5 uses?
I would say so. I think the main part, as I said, for Discovery version 5 is the Kademlia thing, and that's also what discovery version or the earlier versions of the discovery protocols use. I'm not sure if like particular discovery version 5 is a good idea, or if we should just use Kademlia DHT as part of libp2p, because the discovery version 5 is built on top of the dev P2P stack, and as far as I see, we are not really wanting to go in this direction.
Correct me if I'm wrong, but the discovery v5 could be utilized within libp2p, correct?
So from my point of view, I think we could, and I can help with this, we can do a gap analysis between our DHT implementation and the behavior of the Ethereum 1.0 of the DevP2P DHT implementation. And because there are some differences in behavior, and these ultimately libp2p intends to be a stack that is usable for for any downstream user that is intending to build a peer-to-peer application. So really these different behaviors should make it as customization or configuration flags into the libp2p Kademlia implementation. So I would be happy to do and to collaborate with others on this short analysis, identify those areas where we differ, and push tickets and push changes on our DHT implementation to make sure that we are aligned, or it is possible to align our behavior with that of DevP2P. So then you'll be able to build, anything that's necessary for discovery version 5 on top of libp2p. This is just an idea. Curious to know what you think.
That sounds reasonable to me. Have you, or has anyone from libp2p been in touch with Felix to this point?
Oh yeah, of course. We had a meeting with him, with Guillaume as well, and yeah, we're super happy to collaborate.
Okay, cool. Well, maybe we'll push forward on that outside this call.
Yep.
I believe the critical feature, at least that led to the adoption of v5 in status, was the fact that you could negotiate peers with specific capabilities, so that you know that the peer you're looking for has support for a particular feature. In our case, obviously it was Whisper, but like that's something that I think we should name as a hard requirement for any discovery protocol that we have, that it has this built-in capability of feature discovery of the peers that you're talking to.
That totally makes sense, and particularly in the libp2p roadmap, there is one goal, one point that speaks very loudly to this. Service discovery, right? So it is not, we're intending to build an abstraction for service discovery that can be driven by Kademlia, but can also be driven by other mechanisms and other discovery protocols, which might be local or might be connected, or they might be over a local network, or they might use different mechanisms. And one of the protocols that came up as well in Prague was some research work that had been done in a group membership protocol called BRAMS, and I know that some other teams were also looking into that. So yeah, that definitely warrants more investigation.
Okay, we'll try to dig deeper into these things between now and the next call. Hopefully we can coalesce on a decision relatively soon. Okay, anything else P2P discovery related before we move on? Okay, great. The next thing is validator privacy and roles. There's an ongoing discussion around validator privacy in the P2P research repo. Does anybody want to speak to that and the conversation that's been happening there?
So I think we agree all there that validator privacy is somewhat important. There's no concrete outcome so far yet, but maybe one thing we should discuss is one suggestion to have multiple proposals for each slot, and they so that if one proposer is attacked, then there's still another one who could replace him. Yeah, just wanted to mention that. I think Nicola proposed that.
Vitalik, you had some thoughts on that, right?
I mean, I briefly mentioned the possibility of using some ring signature or some other linkable one-event zero-knowledge proof to prove that you're a validator without revealing anything else. But I don't think I said anything more detailed.
Oh, I meant about multiple proposers per slot.
Oh, sorry. Yeah, I think it's just fairly complicated to implement at this point, and also it runs into kind of potential race conditions where, like, what if one proposer ends up getting delayed by 1 second, and then another proposer kind of opportunistically decides to make.
You cut out.
Sorry, I'm back.
Cool.
Yeah, so it's like those kinds of things that I'm trying to that we risk if we kind of put too many start doing those kinds of things. Like, the nice thing about the one validator per slot approach is that it makes it sort of pretty simple, and then you have this nice big fat 6-second window within which to either propose or not, and if you don't, then someone else does.
Right, and the zero knowledge proof or ring signature like construction was in an effort to fight against the potential eclipse attacks of like the shard subnets, right?
Yes.
All right. I think that's definitely a valid train of thought to consider. I suppose the design goal right now is to make the validator as distinct from their position in the network as possible, such that validators can create whatever node setup or set of node setup that makes sense for their security concerns. I know that's slightly just kicks the can down the curb, but I would err on the side of simplicity on the base protocol unless we have a very compelling solution to increase the privacy native to the protocol.
Hey, Danny. So if we could talk a little bit about, with respect to like the role of validator with respect to syncing. So like we spoke a little bit offline about kind of how perhaps the beacon node could be in charge of syncing the shards, and then they can hand off the data to the validators. However, like at Prismatic, we've been discussing this. We don't understand why this sidecar approach is that effective. Why can't validators just be in charge of syncing shard chains?
I think the general distinction in this software is that we have a client piece of software that can run and process the entire blockchain, the beacon chain, and the shard chains. And that the validator is this special user piece of software that connects to and talks to a client piece of software. I think once you put in shard syncing and node peer management into the validator piece of software, you now have two nodes now, rather than you have two node pieces of software, and you make the barrier to entry to create a validator piece of software very high. I think the distinction of the validator being very thin, the validator controlling keys, controlling secrets, and signing things allows for incredibly diverse setups. A validator could talk to 10 different nodes, controlling them via commands, sync this shard, sync that shard, ask information about the shards, sign information, and broadcast as they please. But putting actual block processing and consensus rules embedded into that piece of software, I think is not going to give you the diverse. I think it's not the design decision that gives us the most optimal set of potential setups. Another thing that this does is that as long as you keep the validator secure, he can talk to whatever nodes he wants. Those nodes don't, I mean, if he has 5 nodes that he's communicating with, and one of those becomes hacked or one of them is DOSed, it has redundancy in talking to multiple ones. If it's instead in charge of syncing its own data and connecting to peers, then it becomes a single point failure. I think that's my general design philosophy, is that the validator is this user piece of software that connects to a node or many nodes, just like any other user piece of software that might connect to a node. And a node should be just general purpose and be able to sync the beacon chain, which is the system level stuff, and shard chains. That's my general design philosophy. Obviously, it can be debated. Thoughts?
Yeah, we actually had a very, very similar discussion the other day when we were looking at this setup, and we haven't quite concluded that discussion, but the same thing was brought up, that the centralization of the all responsibilities to the beacon node, including syncing the shards, is a little bit odd, in the sense that the validator exists to unify what's happening in the shard with what's happening in the beacon chain, basically. And perhaps a way to address this is that we keep the two command APIs a little bit apart, the one that controls the shard and the one that controls the beacon, or the API commands, so that we don't conflate them into a single unit. And what that allows is basically running a beacon node, a validator, and a shard syncer separately if you desire to do so, but it also allows you to implement the beacon node.
Sure, the shard syncer cannot exist without the beacon node. Like a shard needs to know information about the system level stuff for it to remain in sync.
Yeah, but that information can be passed somehow between them, right? Separately.
It would need to be passed between them basically in real time.
And then all of a sudden you become like, the validator becomes this like middle, it's more than just this entity that's participating in signing and consensus. Now it is like a core piece of infrastructure for a node.
All right. I need to think more about that.
Yeah, we can debate this till the end of time, I'm sure.
So we've been talking about this a bit too, and something that the way that I was thinking about it was that a validator has this schedule that they need to operate on. So they need to gain from the beacon node this idea that there's like over these periods, over these slots, they're going to have to create some action. So there's like this scheduling system. So the solution that I came to that I thought was most sensible personally was that the scheduling lives inside the validator client. So it's up to it to retrieve its schedule and then to maintain it. And so it should kind of prod the beacon node and say, hey, you need to sync these shards. Hey, I want you to produce a block. And I liked that because it means that the validator can swap around between nodes. And something that I thought would be quite important for a validator service is it needs to be able to have this idea of the quality of service that it's obtaining from a beacon node. So if it maintains this schedule, it can kind of start to have this idea that it's not getting responses from the beacon node and it can swap around. Whereas if that kind of schedule lives inside the beacon node, then, then if the beacon node falls over, there's nothing really checking on it. So I think my what I was thinking seems to link in with what Danny was saying. Is that right?
Yes. And Yasser, if you decouple shards and beacon nodes as two separate pieces of software that need a validator to kind of control both of them, you now can't run a beacon node you can't run like a sharded you can't run a shard chain beacon node without a validator because you need that piece of like middleware. I see the validator as it's a user. It's a core user piece of software, but it's a user piece of software in the same sense that like the commands, the validator has, as Paul said, has a schedule. It knows it's asking the system, the beacon chain, what the current shuffling is, and it sees there's an update, and it knows, oh, I need to sync this shard. So it issues a command to the node, sync this shard. And then when the slot comes for it to attest to it, it says, what is my attestation candidate? And the beacon node says, like, for this certain piece of data. The beacon node passes that, it signs it, and passes it back.
Yeah, I definitely support the modular approach. By the way, I have to head off, so great chatting and listening with you all.
Later, Vitalik. Okay. Let's pick a place. I'll make an issue around this, and we can continue to talk about it, and maybe even like set up a call next week where we can dig in and debate even more. Clearly, there's a lot of design decisions going on here, and to be fair, if you create a client and a validator and it executes the protocol, that's fine. The reason that we would have this conversation right now is so that we can coalesce on some sort of standard interface such that these systems become more modular and people can create more sophisticated validator setups. But again, at the end of the day, if you create a piece of software that implements the protocol, it implements the protocol.
Yeah, I was going to say there's also implications for, the impending staking pools, and how this design, could affect how that's implemented. We also want to I would think we would want to encourage a more decentralized approach to staking pools rather than, some sort of like monolithic setup like how mining pools work right now. So maybe that's worth, just at least keeping that in mind.
Yeah, absolutely. And I think by exposing the minimum generic functions to operate and control these things, that we can move in that direction. But any other comments before we move on? I clearly I'm very opinionated in this, but I'd love to continue the conversation and maybe an issue, and then we can get all of our ideas in one place. Sounds good?
That's good to me.
Cool.
Sounds good.
What is next? Yes. Raul has mentioned a few times that Lit2P is figuring out their 2019 roadmap. Mainly just wanted to make y'all aware of that. But since Raul is here, you want to give us just a briefing on that?
Yeah, so this is really an open call for participation in the roadmap. We are defining together, and this is really the community as a unit. We're defining together what we want to focus on in the future, not just for 2019, but even in terms of vision and in terms of where we want to take the technology and the future of peer-to-peer networks as well going forward. We are expecting we ideally want to lock down kind of the wish list of all the items. And right now we're at a collection, sort of like at a brainstorm point where we're collecting input from many communities. And of course, Ethereum being a very good friend and a primary stakeholder as well in the P2P, I think it's very important for you guys to pitch in, to look at what we have so far. Thanks, Xiaowei, for posting the link. And yeah, definitely point out where we need to pay more attention, what is a priority for you, what, different ideas or different things that we should take into account, and really we as a community in general. So right now, as I said, this pretty much reads like a wish list so far. And yeah, basically the process right now we are collecting these ideas. By next week or the 2 weeks after this, we hope to have prioritized these ideas and in general build a roadmap and a timeline to deliver them. for 2019 and forward. And we really want to. We're also working with an OKR process to keep ourselves accountable and to keep the community in general accountable as well. So yeah, we basically at this point, that's all I can say. Just invite you to collaborate, to read up on this, and we hopefully will have locked down kind of like the wish list by the end of this week.
Great, thank you so much for joining the call and helping out earlier and telling us about that. Please take a look at that. As you said, you know, we want to get the features in that we want. Okay, next is just general spec discussion. Questions about the spec in general, things that have changed, anything on those lines. And as always, I'm generally very responsive on the sharding getter or direct message if you have any questions outside of this call.
I have a question regarding persistent chain splits. So the spec doesn't really go into this much, but what happens if something like a DAO, the DAO situation that happened several years ago were to happen and people would want to split in Eth2.0? How would that work?
There's a general versioning structure in there to handle splits and to handle forks, whether they be contentious or not. And so what the versioning does is it essentially puts signatures into separate domain such that people running a previous version of the software are not colliding their signatures with newer versions of software. So in the case that somebody wants to coordinate a permanent persistent fork, they would use that mechanism to essentially run a slightly modified version of the software and to ensure that their signatures are in a different domain. That's the short answer. These things depends on the nature of the split, why the split happened, what actually, what people were changing with the protocol and with the code. But in general, there's kind of with the versioning mechanism for the signatures, I think it's kind of under the idea of domain and version in the spec, if you want to take a look at that. There is a built-in mechanism to handle forking or replay protection. In terms of the shard data chains and state execution, I don't know. I imagine there will be this mechanism will be utilized for the signatures across, and so in general, that would be that would satisfy the shard chains as well as the beacon chain.
Another question that I have is, does anybody have the notes from the Stark's working group from Prague?
I just shared them yesterday. The guys from Starkware got me notes last week that I cleaned up and added to that document. I will share them in the chat and on the Gitter again shortly.
Thank you.
Mm-hmm.
So I've been reading the spec a little bit, and since there's a lot of changes going on now, maybe I should just mention a few things. They're more like general comments, but one thing is the use of unsigned integers, right? If you're looking for bugs, one good source to find them is basically unsigned arithmetic. I've noted a few places where simply because Python uses integers and the order of operations might not matter, whereas with signed types you have to consider these things. I don't know how much the spec wants to deal with that really, but it's something to look out for. I guess a broader issue is that now that we have uint64 everywhere, whether we can get some guidance on reasonable values for these, like take something like a slot index, for example, slot number. We don't expect that to span the whole UN64 range, but what would be minimally acceptable numbers for implementations to accept, to be called, you know, conformant to the spec or whatever. It would be on my wish list. Another idea I had was that some of the data in the beacon, in the state, is slightly redundant, and I think the biggest one would be the shard committees. Basically, this is something that's derived from a different field in the state. So as far as I'm concerned, it would perhaps be more simple if it wasn't in the state, but rather that it was fetched at the beginning of processing, and then what client implementers can do is cache it if they wish to.
You're right. That's an interesting one. We've debated a little bit internally. By removing it from the state, you lose the ability to serve it and to serve portions of it, say to light clients, and you put the requirement of doing the shuffling and maintaining the shuffling at all times on every client that is in the node in the network. So that's why we have kept it in it at this point. But I do agree there's a trade-off either way.
Yeah, in the sense that it doesn't really add to the entropy of the block hash or anything, and it does add a bit of complexity to keep it maintained. Like, it adds a bit of complexity to the spec itself to keep it maintained, and later we're gonna feel that complexity in test cases, and if we ever want to formally verify the spec and so on.
Thoughts on losing the ability to serve it to light clients if you take it out of the state?
I can see that as a separate service, to be honest, if it's needed.
I was also thinking about some parts of the state that could not be in the state, like recent block hash, for example. And after some time, I realized that, for example, in a fast sync in Eth2.0, you download in the state, and you have to download like 256 previous blocks to serve. To run the VM correctly, and that's what you will have to do after downloading the state. And if there is no shards and committees and recent block hashes and all the stuff that you could possibly calculate from some recent blocks, you will have to download those blocks and process them. But if you have everything in the state, you could download the state and start syncing from that point, something like that. So it's pretty handy in this case.
Right, and one of the general goals has been that the state plus the previous state plus the recent block, you can calculate the entire state transition function from the state, and that's why those recent block hashes are in there, because they're to utilize to verify attestations on these epoch boundaries. Once you take that out, then you put a lot more, you make the state encompass multiple blocks and it kind of caching, and you have the state's still there, and to process everything, you still need the state locally, but you just, you've kind of hidden it rather than making it very explicit what the requirements for that pure function are.
I think that we should keep as much in state as needed for processing and for this rule for transition, that you can get the state from just the previous state and from the current block you're processing, and until these become a bottleneck in some way.
Yeah, maybe why I picked the sharding committees was because it stands out as being very large in the sense that, yeah, it's the whole validator set repeated twice, yeah, in terms of numbers of items. And it's also trivial to sort of compute it from the other data in the state. So it's more of a question really, and not a suggestion yet. I'm just wondering what the thinking is here.
Yeah, I agree, but we need some numbers, at least in terms of how much disk space we will need for storing, like, I don't know, some generations of this state. So just need to understand how much it will take.
Yeah,
how
and
big the overhead will be.
Yeah, the sharding committees, if we store the shuffling hash very explicitly, like what shuffling hash they came from, you're right. It still satisfies that pure function in that the state transition function takes the previous state and the block. It computes the shuffling and processes the block and outputs the new state. So in that sense, it does still satisfy that requirement. It just puts this kind of implicit, it puts this shuffling requirement on every node. We can open up an issue and debate that there. Sound good?
Yeah, good to me.
Yeah, works.
Cool. Any other spec-related items?
Yeah. So issue 129, there's some debate going on around the use of simple serialization versus protobuf. I'm not versed enough on that to speak to it, but I'd like to kind of get some thoughts because we're in the middle of doing a simple serialization implementation.
I think regardless of what we use on the networking layer, if we move toward protobufs, that we're going to use simple serialize with the tree hashing algorithm for the actual hashing of the state. And so I wouldn't say that's a blocker on you right now, and that you should implement simple serialize. As for the ongoing network serialization debate, is there any, I haven't been following that one closely, is there any updates on that, any new thoughts? I saw that some people wanted to run some numbers maybe on protobufs. I'm not certain.
One of the main concerns regarding simple serialization from my side was that it's not forward compatible in terms of adding new fields to any structure. A good example is the chain ID field from Eth2.0. It's been added, and it had to be encoded in an existing transaction structure. Fortunately, it's been done. There was a way to do that, but it would be great if simple serialization has this feature, but it's not essential. Just something that
was chain ID retroactively added to existing.
Yeah, the the data structure had been changed, and chain ID had to be added.
But it was added at some block number, not retroactively, because that would have messed up the hash chain.
Yes, but the format, the new transaction format, the transaction format had to be preserved because it was not possible to change the format. I mean, it wasn't possible because all clients had an implementation of this format as an RLP encoding, and yeah, it wasn't possible just to change the format. I mean, to add some new field to that. And it had to be encoded as with one of signature parameters, within one of the signature parameters. So that could be a good feature for serialization protocol. Good feature to have, but not a requirement.
I think maybe what Danny is saying is that there isn't built-in versioning feature in the protocol already, and technically it could be handled through that.
Yeah, I see. Yeah, got it. Okay.
Cool. Anything else for today? Okay. Thank you. It's incredible to see all the progress going on. Super, super exciting for me. As we said, we think we got most of the major changes and additions to the Phase 0 document done. But over the next probably 5 days, there's going to be a series of just ongoing edits, fixing some naming, reordering some things, things like that to make it a lot more readable. So there's still going to be a handful of pull requests coming, but then after that I expect much more stability from the spec side. As always, communicate on the Gitter. Hit us up if you have any questions. Thank you, everyone, for coming.
Thank you.
Thank you, everybody. Bye-bye.